Okay, this is the second part of lesson 7.2. If you understand the first part, this is really more of the same with just two proportions. We're going to do the difference of the two proportions here. So at school one, 70% of the students did their homework. So P1 is 0.7. That's the population parameter there. School two, 50% did their homework. P2 is the population parameter for school two. The counselor at school one selects a simple random sample of 100 students, records that proportion that did their homework. Counselor at school two takes a simple random sample of 200 students and records that. Those are sample statistics, just to remind you that. Those are the names we're going to refer to those different things. So there are two different populations. We're calling them population 1 and 2, school 1 and school 2. Parameters are dealing with the population there, 0.7 and 0.5. Statistics are whatever proportion we got when we took those samples, and sample sizes N1 and N2. So just so we know how to refer to those particular things. Oops. Okay, so the first, to check the shape, we want to see if it's normal, so we do NP for the first school and NQ for the first school, and we get 70 and 30, and those are both at least 10, so that's good. It's going to be approximately normal. Second school, we do NP, NQ. We get examples of 100 and 100, which are both greater or equal to 10. And so that's good. So if they're both approximately normal, we can say that the difference of the two are going to be approximately normal. The mean of the one school is 0.7, the other one's 0.5. We can subtract those in a minute. And then variability, we do their standard deviation separately there. So square root of PQ over N. Of course, we should always check the less than 10% condition before doing the standard deviation there. So because 100 is less than 10% of the students at this large school with over 1,000 students. Same thing for this one. Hopefully that's less than, if it's a college or a larger school, like Iowa or something, then 200 is less than 10%. So assuming it passes all those, what can we say about the difference in the sample proportions? Well, the difference in sample proportions, the mean of p hat minus mean of p hat 2, if it's 1 minus 2 would be 0.2, 0.7 minus 0.5, so 0.2 should be in the center, it is. And then this just explaining one dot, what does that dot mean? That means there was a difference of 0.25 in those two samples that they took, but there's lots and lots of different samples there. They did this many times. But of course, 0.2 is the mean of the sampling distribution there. Remember to find the standard deviation. Remember using this formula. So you kind of have to do standard deviations different. You have to kind of PQ over N plus PQ over N. We add, even though we're subtracting, the standard deviations are going to add. So instead, square root of PQ over N is square root of PQ over N plus square root of PQ over N, as in all together there in one different thing. So we'll just plug in those numbers for those two different proportions and get the standard deviation of the difference there. So just kind of a formula there. I'm pretty sure that's on your formula sheet. Let me see if it is. So you can see on the formula sheet, this is on the top of the second page, I think. So on the left top here, for one population, there's the square root of PQ over N formula. For the difference in two populations, P1 minus P2, the standard deviation is square root of PQ over N plus PQ over N, like all together there. So you've got that formula. In case you need it, it's there for you. They also give you standard error, which you don't need for this one. Okay. So that's where that formula comes from. The sampling distribution of the difference of the two proportions is approximately normal. If the large count condition is met for both samples, we checked it for both and it does. The mean of the sample is exactly what you think, just the difference in the two. The standard deviation, again, use that formula as long as it meets the less than 10% condition. right? So it's got to check that before you do the standard deviation. It's exactly correct. Only we have two types of independence. Independent samples is exactly correct. When sampling without replacement, the actual value is smaller than the formula suggests. However, if the less than 10% condition is met for both samples, it's pretty close. So, and that's usually the case. Usually we sample without replacement, so they're not always completely independent. Okay, so this one is the sampling distribution of a difference between two proportions. Teacher brings in 2 bags of colored goldfish, crackers to class. Bag 1 has 25% red crackers. Bag 2 has 35% red crackers. So 2 different proportions here. Each bag contains more than 1,000 crackers. Using a paper cup, your teacher takes an SRS of 50 crackers from bag 1 and a difference SRS of 40 crackers from bag 2. P1 minus P hat 2 be the difference in the sample proportions. What is the shape? So what do we have to check for that? We've got to do NP greater than equal to 10. So you get out your calculator and you go, okay, let's do, I think it was 50 for the first bag. So 50 times 0.25 and 50 times Q, which is 0.75. Then 40 times 0.35 and 40 times Q, which is 0.65. So those are all at least 10, so it passes that condition. So because we checked it for both sets, we can say this is approximately normal because all are greater than or equal to 10. Find the mean. So the mean is pretty easy as P1 minus P2, so 0.25 minus 0.35, which would be negative 0.1. Calculate and interpret the standard deviation. So you can use that formula there that we just talked about, so square root of 0.25 times 0.75 all over, I think that was 50, plus still underneath the radical there, 0.35 times 0.65 all over 40, I believe, for that one. Should be 0.097. 0.097, okay? And so, and we should also check that it's less than 10%. So don't forget to do that because 50 is less than 10% of all the crackers, less than, there were at least 1,000 in each bag. There's quite a few. So 50 is less than 10%, 40 is less than 10%. So that's why we were able to figure out the standard deviation using that method. It's greater than the proportion of bag for sample 2. So you can draw the normal curve, using the mean and standard deviation we just found. Do your norm CDF, in this case 0 to infinity, with a mean of negative 0.1, the standard deviation of 0.0971, just to check, because I would have gone to infinity there. I'm not sure it should be 1,000. Let's see how much different this would be. Probably not much different at all. Menu 652. So I think it should be 0. I probably would have put infinity there. Let's just see if it makes a difference. Mean was negative 0.1. Standard deviation was 0.0971. That doesn't make much of a difference, does it? Yeah. I just said 1,000. Not sure why they said 1,000. I would have said infinity. Okay, just another problem, same type here. So what is the shape? What do we have to check? To check the shape, you'd have to check very large high school, junior class of 800 students, 54% are female. Senior class of 700 students, 49% are female. The student council selects a random sample of 40 juniors and a separate random sample of 35 seniors. So P hat 1 minus P hat 2, essentially the juniors minus the seniors there. So what is the shape? So to check the shape, you've got to do 800 times 0.54. So 800 times 0.54, 800 times 0.46, I believe. and then 700 times 0.49, 700 times 0.51. So those are all greater than or equal to 10, so we're good to go. What is the shape? Approximately normal, because all of those, it meets the large count condition. Find the mean of the sampling distribution. That shouldn't be too bad. It's P1, P juniors minus seniors, so 0.54 minus 0.49, which is 0.05. Calculate, interpret the standard deviation. So in that one, again, we get to get the calculators out and do the formula. So square root of the fraction would be 0.54 times 0.46 all over 700 plus 0.49 times 0.51 all over, what was the number? 800 for that one, 700 for that one. 700 for this one. I think I made a mistake. I think that should be 800. 0.025. What did I do wrong? I messed up 0.54 times 0.46 over 40. Okay, so n is 40 and 35 there for this. The total number of students was 800. I didn't catch that, sorry. You have to make sure you get your n and p and q correct there. So that makes sense. They took samples of size 40 and 35 there. Okay, so estimate the probability that the proportion of females in the sample for the junior class is less than the proportion of females in the senior class. So we got these two values, the standard deviation and then the mean proportion there. So we're going to add one standard deviation out would be 0.166, I think. Subtract. This gets just hard enough. You might want to use your calculator at some point here. So 0.05. I like to do it this way. I press enter, then I hit minus 0.116. Hit enter 3 times. Those give you the next 3 values. So negative 0.066. Negative 0.182. And so forth. So what do we need here? So we need to answer the question that the junior class is less than the proportion of the senior class here. So if the juniors, the first one, is less than the seniors, so a smaller number at the beginning would make it negative. So I really want anything from 0 and above. So kind of think of that as 0, shading above, anything above that. So then I would get your calculator out. Menu 652. Lower bound is 0. Upper bound, I would say infinity. And then the mean was 0.05. Standard deviation was 0.116. So 66.6% should be your answer. Oh, wait. We want it to be negative. I said it, and then I did it the wrong way. Sorry about that. It'd be 1 minus that. We want it to be negative, so you would norm CDF that guy. And for the lower bound, it would be infinity, comma, the upper bound would be 0. Okay, so I probably should put negative infinity for the lower bound. That's the default anyway, by the way. Yes, there we go. And we get the right answer. So you do have to pay attention to what they're asking for to get that. That's the percentage that would be for the juniors to be smaller than the senior class, their proportion. Okay, great. That's your lesson for today.